Let's talk about the different representations for um, your conformations. So your conformations can either be represented as a wedge dash, right, or a sawhorse, or a Newman projection, right? So conformations, they can be represented with any three of these, right? I gave you we sometimes consider this 3D because of the wedge and dash line. I'm going to explain what these mean. So we have this structure, and I did a ball and stick, the corresponding ball and stick, because I'm going to use both to explain. Um, the sawhorse is supposed to represent, that toy looking that's made from board. Yeah, you should. That's what it's supposed to look like. The sawhorse. That's what your sawhorse looks like. Then I'm going to use the sawhorse to show how to draw a Newman projection. Let's get started with what this wedge and dash line representation of your conformation means, right? So let us look at so this 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 representation has wedge and dash lines. Let's establish what those mean. A wedge line means that it's coming out of, in this case, whatever device you're watching on, it's coming out of that device into your face, okay, towards you. So take a pen, for example, take any pen, if you eye pen, even better. Put it in the middle of your screen. Your screen represents the carbon, right? So the carbon is in the plane of the board, right? Your screen represents the carbon. The hydrogen that is wedged is your pen. And that pen, you see how that pen is pointing towards you? Imagine the entire pen is your wedge. It's coming out of the computer towards you. Your dash lines, anything dash, mean put that pen to the back of your device, laptop, iPad. That pen that is protruding from the back is what that dash hydrogen look like. The pen will represent the bond, right? It's coming out of the back. Now, anything that is not wedge or dash and is just a singly bond is in the plane of your device, in the plane of my iPad screen. It's not protruding out like the pen coming towards me or protruding from the back, okay? It's in the plane of the your device. It's not coming out. It's not pointing out or protruding from the back, okay? So let us look at this from this structure and this structure. So here, this hydrogen, this hydrogen, all of this is in the plane of the board. They're in the same plane. They're sitting in the plane of the board, which is my device. You're sitting in the plane of my device. Let me highlight that on your molecule. This is that red hydrogen, carbon. They're all in the same plane. They're not coming out towards me or pointing away from me. Okay? Your wedge hydrogen here is this hydrogen, right? If you look at it, let's make it a little bigger. If you look at it, if you look at it, you will see that the hydrogen, let me just move it down a little bit. All right, here we go. So if we look, you can see, let me just make it a little smaller. All right, here we go. So let's talk about it. Let's put that blue line back in here. That's all that's in the plane. This hydrogen is this hydrogen right here. It's coming out towards you, right? This one, which is protruding to the back, is away from you. That's why when you put your pen behind your device, that's it being away from you. That's this carbon right here. That's that hydrogen, sorry, right here. Right? Let's look at our green hydrogens. This green hydrogen is in the plane. It's not coming out or pointing away from me. It's not coming towards me or pointing away. It's in the plane, right? Now, the hydrogen that is coming towards me or out of my device is this one. It's pointing towards you, right? And that's what the wedge does. It points towards you. This one is pointing away from you, right? So this one is away. This one is pointing towards. So this is towards, which is the wedge, right? And then the one that is away from you, let's gonna make it red. It's this one, right? So this one is the wedge, is the dash. Remember, your wedge means pointing towards you, right? Or coming out of the screen towards you. The dash line, so wedge means coming out of the screen towards you, pointing towards you. The dash line means it's going away from you, right? Away from you or pointing, protruding through the back of your screen. So wedge is towards, dash is away. Anything that just has a bond is in the plane. It's not coming out. It's not coming out towards you, and it's not protruding in the back. All right, so that's that. Let's get rid of this. All right, now, so that's solid. That's your wedge and dash line explained. Let's look at your sawhorse, right? So this is your sawhorse, right? This is our sawhorse representation, and all of these representation they represent ethane. So these the examples I'm using here, they're all ethane. All right. The red bond, the red hydrogens, green hydrogens, it doesn't matter. I'm looking at ethane. Okay. Now let's look at our sawhorse. So for our sawhorse representation, right, we're gonna use the sawhorse to explain how you draw your Newman projection. So for our sawhorse, this is the carbon, and we consider the carbon, we consider this to be the carbon in the front. It's the closest one to you. It's always bonded to the carbon in the back, right? The carbon in the back is the one furthest away from you. So this is your front carbon, CF, back carbon, right? Bonded to each other. Carbon in the front has a hydrogen, right? That points straight up, and then two to the side, right? Your carbon in the back has two green hydrogens protruding off. That's what those two are, and one straight down. That's that one straight down. So that's what your sawhorse looks like. To convert the sawhorse or to draw in general your Newman projection, the sawhorse is rotated until the front carbon blocks out the back carbon. So you as the observer is here, right? This is where your eyes are. And you look at the front carbon, right? In a way where it blocks out the back carbon. That's how you draw your Newman projection. So this sawhorse can be oriented to where the front carbon blocks out the back carbon, which is why you don't see it. So you can turn this to get this, right? To where just turn it until the front carbon blocks out the back carbon completely, right? So it's like you have this, just turn the molecule. Front carbon blocks out the back carbon, which is why you cannot see it. So when we draw the Newman projection, this is how we do that. Front carbon, this is the front carbon, this is the back carbon. Always remember the front carbon is bonded to the back carbon. Your front carbon is right where the three bonds meet right here in the front. These three bonds, wherever they meet, that's your front carbon. That's the front carbon, okay? If you look at the front carbon, here it has one hydrogen pointing straight up. That's what this is, right? On the left, you have one hydrogen. That's this hydrogen, right? Notice you're keeping the same pattern. One hydrogen, one hydrogen, one hydrogen. So it's this hydrogen corresponds to this. This one corresponds to this one, and this hydrogen here corresponds to that hydrogen. All right, so that's the front carbon. The back carbon is this big circle here in the back. This big circle represents the back carbon. Now let's look what's on our back carbon. This is our back carbon. I have two hydrogens pointing off to the side. That's what these are, right? And I have one hydrogen down, straight down. That's this hydrogen. That's how you draw your Newman projection. You need to, and if we look, let's look at the ball and stick. Here's the front carbon completely blocking out the back carbon. That's why you don't see it. These green hydrogens, they are on the back carbon, but because I orient the molecule so that the front carbon blocks out the back carbon, you do not see the back carbon. Here's my front carbon, right? You have one bond straight up and two to the side. Straight up, two to the side. In the back, right? Circle represents the back carbon. You put on your two hydrogens and the one that points straight down. So your Newman projections, the key is make sure you know which carbon is your front carbon. Once you find the front carbon, just look at what's bonded to it and how it's bonded. If it's straight up, you got to keep it straight up here. To the side, to the side. I am going to make some videos on how to convert formulas into Newman projections. So that's something that we will look at. But yes, Newman projection, just remember where the three bonds, because these are bonds. This is a carbon, right? These are the bonds to it. Just remember wherever the three bonds meet is where your front carbon is. Your back carbon is the big circle. That's the back carbon. So just put back what's on the back carbon. That's how you convert. That's how you draw your that's how the Newman projection is drawn. Things get a little different, and we'll talk about that when you have to convert your when you have wedge and dash lines to convert into Newman projection. I'll do a video on that. For this one, we're just showing you how the Newman projection comes about because most of your representation, especially comparing energies, etc., is done through looking at the Newman projection. So front carbon, back carbon, and you just put what's on the front and the back carbon.